Hello everyone, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and I'm here to solve a classic Sudoku created by Carrick22. This Sudoku has been taken from the Logic Masters Germany portal. I will add the link to all of this author's Sudokus in the description of the video. You will also find the link to solve this Sudoku in the description. Please do give it a try and come back and watch the video. This is a live solve. I hope this is enjoyable for you. So the rules are normal. Each row, each column and 3 by 3 box in the grid will have digits from 1 to 9 without repetitions. These are the rules, and with that we'll start the Sudoku. So let's start by placing corners. It's been quite a while since I solved a classic Sudoku. I've been covering variants mostly on the channel recently, so this would be a nice change for me. So column 7 and 9 have 1s in them, so that gives me a 1 in here. 1 is in row 2, row 3 gives me a 1 in here. 1 is not in row 4, 1 is not in column 4 gives me a 1 here, and these 3 cells are going to take a 1, which I'm going to refrain from marking. I'm just going to pencil mark only when there are 2 possibilities. Okay, so we can just go to a different digit maybe, because ones have lots of possibilities here and there is no idea where the 1 is going here. So let's look at a different digit. 2 in row 1, row 2 gives me a 2 in these 2 cells. Okay, again 2's don't help us much. Lots of possibilities for the 2. Okay, let's go to the 3's. 3 is in row 1, row 2, so we get 3 in one of these 2 cells. So we have locked 2 digits into 2 cells, which means we have got a pair. 2, 3 in here. Again 3 is also scarcely given. Bottom 3 boxes, if you see, do not have any clue about where the 3's are in. There are many positions for the 3's. So let's go for the 4's maybe. Just a moment, I'll look at the 3's again. Okay, nothing in for the 3's. So if you look at 4's, we get a 4 in row 6. That gives me a 4 in here. Okay, this is nice. So if you look at row 3 and ask yourself, where does the 4 go? 4 can only be in these 2 cells. It cannot be here and it cannot be here. So 4 goes in here. And 4 in box 1 has only 2 positions again, either this cell or this cell. So it's kind of a cross notation of corner pencil marks. And 4 cannot be in row 8, 4 cannot be in column 6. So 4 goes in these 2 cells. Okay, so I think 4's are done as far as pencil marking is concerned. Let's look at 5's. 5 is not in row 5, 5 is not in column 8, so 5 goes in these 2 cells. And 5 has 3 possibilities in box 2. Again 3 possibilities in box 3. Okay, 3 possibilities in box 4. Okay, box 7 has again 3. Okay, this is good. 5 in box 8 cannot be in row 7, cannot be in column 5. So it goes in one of these 2 cells, and that gives me 5 in one of these 2 cells. Okay, so 5's are done. Let's go to 6. Not that you need to solve any classic in order in the way I'm doing. It's just that in this particular Sudoku it is kind of going in order. So it does not need to be the case in all Sudokus. So 6 in row 5 and row 6, which means I get a 6 here, and with this 6 I get my 6 here, and that gives me a 6 in one of these 2 cells. So it going in order kind of keeps the solve in an orderly fashion, you know. So that's why I'm just trying to do that. Okay, 6 has many options in here, again many options in here, and 3 options in box 3. Okay, so there are no more boxes where we can mark 6's in the form of a pointing pair. So a pointing pair is nothing but in a box, in a straight line, vertical or horizontal, you make a corner pencil mark of a digit, then it becomes a pointing pair. For instance, this is a pointing pair of ones, and even this is a pointing pair of 6. It's pointing towards this direction. Okay, let's go to the sevens now. 7 is in row 7 and row 8, so that gives me 7 in one of these two cells, and 7 goes in here in column 3. And if I quickly scan the rest of the boxes, there is very little information as to where the 7s can go. So I'm just going to ignore the 7s for now. Let's go to the 8s. 8 is in column 1 and 2, so that gives me 8 in here. 8 is in row 7, row 9 gives me 8 in here. 8 in row 4, row 5, row 6, and column 6 gives me 8 in here. Okay, and that's about it. We do not have any more information regarding 8s. Let's go to the 9s. There are only 2 given 9s in the grid, as you can see. So 9 goes in these two cells, and which means we have locked 8 and 9 into these two cells. There is an 8 9 here and 8 9 here, which gets locked in here. So this becomes 8 9 pair, and the moment you do this, the 1 is removed from this cell, and you get, oops, we can remove the 1 from this cell, and 1 gets pushed here, and that gives me a 7 in here. So with this one, can we do something? Nothing much. So 9s do not have any information on the top boxes. So let's continue now making center candidates. 4 5 8 9 1 2 7. So we need a 3 and a 6 in this box, and that completes the box. So with this 6 we can remove this, make it a pair. So let's look at row 7 now. Now it's time to look at rows and columns, or even boxes which have less digits. I mean lots of digits. 3 5 6 7 8 9. So we need 1 2 4. This is 1 and 2. This is 2 and 4, and 1 2 and 4. Let's look at this box. This row, sorry, row 9. If you look at row 9, 1 2 7 8 9. So 3 4 5 6. You can't have 3 5 here, so this becomes 4 6, which allows me to make a corner of 3 5 in here. Okay, so if I look at this domino of cells, 7 8 9 cannot go in there, and 3 and 5 are in row 9. So this domino cannot be 3 4 5 7 8 9. So this must be a 1 2 and 6, and 6 is in here. So this is 1 and 2. That is nice. So it became a by value candidate. 2 possibilities only. Let's look at column 9. It is close to completion. 1 2 8 4 6 and 7. So it must be, oh, you can place a 3 here, right? 3 in column 8 and 9. So that gives me a 3 here, which places the 5 in here, and that means I can get the 5 in these two cells. Again, some corner marking. So I got the 3s. So 3 goes in one of these two cells. So we can finish column 9 with a pair. So this becomes a 5 9 pair, and because of this 5, I get a 5 here and a 9 here. That gives me more corner pencil marks. 5 goes in here. Okay, 6 goes in here in column 8. Okay, we can populate these cells. They must be 2 7 and 9. And which means if you look at row 5, and where does the 1 and 3 go? So we can make some corners in here. So 1 and 3 goes into these trimino. You can say 3 cells. And if you look at this cell, this is kind of restricted. It can't have 1 and 3. It can't have 5 and 7 because we have made the pencil marks here. 1, 3, 5, 7, 4, 6 and 8. So this can only be 2 and a 9. Again a beautiful bi-value candidate. So these are the stepping stones, you can say, to find advanced tricks. If the author intends to hide some advanced logic in the trick, this is how they would usually go. Make sure that there are a lot of bi-value candidates in the grid, and then using that to expand a logic. Okay, so look at row 8, and where does the 3 go? 3 goes in these two cells, and which means this becomes a 3-5 pair, right? And because you have a 2 here, so this becomes 1 and 6. And now there is a 1 and 6 here, so which means 2 must be in these two cells, again a corner, so that removes the 2 from here. This is a 1 and 4, and 6 in box 8 must be going in one of these two cells. That removes the 6 from here. 6 is not here, so 6 goes in one of these two cells. So as you can see, we are making a lot of corner pencil marking here. Look at this cell, 1, 2, 3, 4 is here, 5 is here, 6 is here. So this is a 7, 8, 9. And 8 is also removed, so that's a 7 and 9. Okay, so this column 2 is removed from this cell. You have a 2 here, so these two cells become 4, 7, 8. And you have a 7 in here, so that's a 4, 8. Okay. Look at these two cells in row 2. They must be 4, 7, 8, 9. 4 and 9 are eliminated. So that's a 7, 8. And that's a 4 and 9. Okay, this cell, coming back to this cell, this can't be a 7. I missed that. 1, 2, 6, 3 and 5. And 4, 7 and 9. So this can only be 8. That removes the 8 from this cell. So this is not 8, that's 4 and 7. Okay, look at this cell. This is also a hidden single, you can say. 5, 6, 7, 8 and 4 and 9, 2 and 3. So this can only contain 1. Nothing else can go into that cell. So that removes 1 from here, 1 from here. So this would be 4 and 9 for the row. This would be 6, 8 for the box, 2, 5, 9, 1 and 3, and 4 and 7 are eliminated. So this would be 6, 8. Oh, too many bi-value candidates. It's fantastic. So is there something already hidden? Okay, this is nice. 1 cannot be in row 9 column 1. So the 1 in column 1 must be distributed into these two cells, because we do not have. But because of this 1 cannot be here. So that gives me a 1 in here. So this becomes 2, 3, 7 for the row. So the Sudoku is gradually becoming harder, I can feel that. Okay, this 1, 6, 7, 8. So I'm methodically filling the candidate with, filling the grid with candidates. Look at this cell. This is again very less limited in possibilities. It cannot be 1, 2, 3, cannot be 5, 9, cannot be 4, 8. So this can only be 6 and 7. So what are we supposed to see here? I have a 4, 7 here, a 7, 9 here, and a 4, 9 here. So this is a really interesting pattern to me, because what we have, what we would call a Y wing or an XY wing as per wiki terminology. So you need to identify bi-value candidates spread across either 2 or 3 boxes. So in this case, you have 3 bi-value candidates, and spread across 3 boxes. So sometimes this may be spread across 2 boxes also. The main thing is that these bi-value candidates must be some combination of 3 unique numbers. So you can see that you have 4, you have 7 and you have 9, and they are just mixed and matched in some combination. And the next part is that you must have a cell which is seeing the other 2 cells. These 2 cells are the wing cells, and this is called the hinge cell because it is seeing both of these cells. So that is why it is called the hinge cell as per the wiki terminology. So this is what we would call a Y wing. So when you identify this pattern, you can eliminate the digit which is common between the wing cells from the cell which is seeing both of these cells. So you can see that this cell is seeing both row 2 column 2 and row 5 column 7. So if I have a 9, let's say here, sorry, not there, here in the red cell, what happens is this becomes 4, this becomes 7, and there is no value for this cell. So this is called a Y wing pattern. So which means I can eliminate 9 from here. So this can't be 4, 6, 8, 1, 5, 7 and 9. So this is 2, 3. Oh, I was hoping for one more elimination. That would have been ideal. That would have been really ideal, right? So you have 2, 3, 7 in here, which means 9 must be in these 2 cells. That removes the 9 from here. So this becomes 2, 7. Really nice to see so many bi values inside here. So the scope for finding advanced possibilities is very rich in this classic. So what are we supposed to do now? 2, 3, 2, 3, 7. Okay, let me remove these colors now. I'm not sure what we need to find again now. 4, 9, 4, 9. Okay, let's make some pencil marks here. This would be 4, 6 and 8, and this would be 4, 7 and 8. So we got an elimination here, right? Let's see if we can make use of this cell. In this column, 5, 6, 7, 8. Okay, nothing much there. Oh, 1 can be removed from here. This is not 1. And if I look at these 2 cells, they can't be 1, 4, 6, 8 or a 3. So 2, 5, 7, 9. So this is 2, 5, 7. This is 2, 5, 9. Okay. So I was hoping that this would have helped me much more, but it's not helping that much. So 3 is in these 2 cells, right? Okay. Wow, this is beautiful, guys. So we again have XY wing or a Y wing pattern. So earlier we saw that we had a 4, 9, 4, 7 and 7, 9 here spread across 3 boxes. So in this case you will notice that the Y wing is spread across 2 boxes, right? So you have a 2, 9 here, you have a 2, 7 here, and you have a 7, 9 here spread across 2 boxes and some combination of 3 unique digits, 2, 7 and 9. And you can identify the hinge cell in here. The hinge cell is one which sees both the cells. So this is the hinge cell and these are the wing cells. So we can eliminate the digit which is common to these from the cell which sees both of these cells. So we could have eliminated 9 from here, but so this is a pretty useless Y wing, I would say. It's not giving us anything. This can't be eliminated as a 9 because this does not see that cell. So this is a useless Y wing. I was hoping that I got something there. So let me remove that Y wing. It is not helping us. Okay, let's look at this area. 4, 5, 6, 3 and 8 are right away eliminated. So 1, 2, 7 and 9. 2 and 7 can't be here. So this is 1 and 9. This is 2 and 7. So we got more by-value candidates. So 9 goes in these two cells, right? In box 2, we can make a corner there. So this cell can't be 1, 2, 3, cannot be 6, 9, 7. 6, 7, 9. So this is 4, 5 and 8. Oof. That's a lot of pencil marks. Let's look at this cell. 4, 5, 6, 2, 3, 7 and 1, 8 and 9. So this would be 8 and 9, right? Can't be anything else. Oh, I really missed something here, guys. I'm sorry for that. The moment I eliminated 9 from here, I could have made a corner of 9 in these two cells, right? That would have given a lot of information, but I missed that trick. So that gives me a 4 here. That gives me a 9 here, a 7 here, a 4 here, 8 here, 6 here, a 7 here, 2, 9, 7. Awesome. So this is the break-in, guys. I'm sorry for missing that. So that's a 9, that's an 8. So we got the whole box 3, 6 and 9 completed. So 7 here gives me 6 here. So this becomes a 4, 8 pair. And that becomes a 5, 9 pair. And 9 can be instantly used to resolve that. So that is a 9, that is a 5, which means this 5 resolves this 3, 5. And look at this cell. This is a naked single. 4, 6, 7, 9, 5, 8 and 1 and 2. So that's a 3. This becomes 1, 2 for the column. Okay. And this 2 gives me a 9 in here. Gives me 8 in here. This would be 7. That gives 2, that gives 1, that gives 9, that one gives me a 2, a 4, an 8, a 4, 2, 4 gives me a 6 and a 1 here, which gives me a 2 and 6 in here. So this gives me a 3, 3, 7 gives me a 2, that finishes off this 2, 3, and we have 4, 6 and 9. So this would be 5 and 7, and 2, 3, this would be a 3. And we need 1, 4 and 5 for this box. So 5 goes here, 4 goes here and 1 goes here. And with that we have completed this really gorgeous construction by Carrick. What a wonderful classic Sudoku. I think the break-in was finding this wiving, after which we could eliminate the 9 from here, giving us a 9 in here, and that kind of finished the Sudoku, which I missed. I thought there must be more to the Sudoku and I was finding more wivings. So hope you enjoyed this video. We'll catch you soon again. Please remember to hit that subscribe button under the video. Bye bye.